Welcome, friends. Today we are going to see one of the important question, which is how to improve our API performance. This is the frequently asked question in interviews as well. Like when you are an experienced developer, they expect you to how you will tackle the problem of the performance of application. So this will become important. So how we can answer this question? So let's understand this with this video tutorial. Let me get you started. How to supercharge your API performance. First, we need to optimize API endpoint, which is streamline responses, return only necessary data, minimize payload size, and reduce network traffic. What this means? Let's understand this with a coding example. I am sharing some real-time coding snippet here, so stay with me. At the end of the videos, I will provide this link of this document as well. So let's understand the streamline responses. What this means, like if we have created one entity class, there is a field we have taken long ID, name, email, address. These fields, suppose there is only two field is necessary, like ID and name. So we can return only necessary field ID and names. Here, if you see this user repository find by ID, this is the we are returning user DTO here. User DTO only contains two field, which is user DTO is a data transfer object we send to the user. So I am only retrieving user dot get ID, user dot get name. So with the help of this, there is no much load on our API. So it will be optimized with the help of this. Next, understand leverage caching. Implement smart caching strategies to serve frequently asked data quickly. Suppose we are making requests multiple time to the database. It is not best practices, because if we same our request is requiring same product multiple times, we can cache that. So we can implement for that caching here. So I will next we are going to see paging and filtering. Enable pagination and filtering to allow client to retrieve data in manageable chunks. So if we maintain paging and filtering, we can only retrieve specific data. Suppose 100 columns, 100 pages is there. First, we can load 100 pages. Then we can load, suppose 1,000 pages is there. Then first we can load 100 pages. Then to again 100 pages. Like this, we can implement filter and paging in our application. With the help of this also, we can explain this point as well. Uh, with the help of this, we can improve our application performance. Next, we are going to see service decomposition. Break down monolith API into smaller, more modular services for better uh, scalability. What this means, suppose our application is monolithic, which is contain like different all the services contain like all the functionalities. Account is there, order is there, notification is there. These all services we have configured in only one application. So we can modular that services for better scalability. Like we can create first account service, then like a notification service. Likewise, we can separate each module separately. So our application will be scalable. Asynchronous processing, handle long running tasks asynchronously to keep the main API responsive. So any API, here we can see one of the example. Let's understand this with example. To handle long-running tasks asynchronously in Spring Boot, you can use @async annotation along with configuration class. On the configuration class, we can use this async. Here we can see async and enable async. We are using. You need to enable asynchronous processing in a Spring Boot application by adding @enable async annotations. How this will work, we will see. Create an async service. We need to create one async service. contain long running tasks and annotate the method with @asyncs. So this is our we want to perform this task. Here task is taking a longer time, like here 500 second we have mentioned. So 500 second means it's a too long time. So for that we can use @async, perform long running tasks uh, on our services class. Controller to trigger async task. Create controller that trigger the asynchronous task. So here we have created one controller that will trigger our task start task. Then we will with the help of our service class we are executing our perform long running tasks method here. Next, here decoupling API is there given. Loose coupling, decouple API component to improve flexibility and maintainability. This is we are performing in our day-to-day life, but some at the time of interview we don't and remember this, or we forget about this. This also a good example. We can explain this to the interviewer if required. So here we can see uh, dependency injection, event-driven architecture, domain-driven design, and then how we can decouple our APIs, define interfaces for services. So here I have created a service interface user service. Then I have defined two method: get user by ID, save user. Then another service I have created product service, get product ID and save product. So implement the interface in your services. So this we can implement our interfaces in our services. Here user repository, get user by ID. We have auto add auto add user repository. We are implementing this user service in our user service IMPL class. So this user service will be separate and our class will be separate. We are using that with the help of service class. Product service IMPL implements product service, say product. Controller layer. In our controller layer, we can access that services. Uh, Use the interface in controller to decouple the controllers from the service implementation. So we can use that services in our controller, so that will be decoupled from our APIs. We just annotating this here @user service, so that API will be decoupled from our services. Then create user, I use user service. Then product service, here we are using. These are the code snippets. I will share this PDF. I will give you link as well. Next repository layer, we are using repositories. And here service interface, define interface for each service. This allow you to change the implementation without affecting the consumer to the service. Means service, it will won't affect our service on consumers. What is the benefit for this? Like flexibility we have with the help of this component, we will be flexible. We can modify our code. And maintainability, decoupling reduces the dependency between components, making the code base easier to understand and maintain. We can easily understand like what's happening in our API, and services will be uh, like decoupled from components will be less, having less dependency here. Next, we are going to see here versioning, implement versioning strategies to support backward compatibility as your API evolves. Suppose we have developed one user API here, and that we want changes, means our API evolve. So how we can maintain versioning? First, we have created V1 version 1 for our API. For this, you can understand from here at the rate request mapping API version 1 users. So for user, we have created version 1 API. So as our API evolves, get user by ID. As our API evolves, we can create another URL like API This is our first, and this is second API v to users. Client can choose which version of API to use. Means based on our client requirement, he can request to the specific APIs. So what is the benefit for this? Each version of the API is clearly separated. Means we can maintaining version here. So next we will understand leverage caching. In memory caching, we can use Redis or meme cache to store frequently accessed data. CDN caching utilize the content delivery network to catch static asset and reduces latency. Intelligent expiration implement fine-grained cache expiration policies to balance freshness and performance. For this in memory caching, Redis, I am creating separate videos, guys. So subscribe to the channel, stay updated. We are going to see it in next videos. Next, see here indexes. Create strategic indexes to speed up common database queries. We can create strategic indexes on our databases. So our API response will be uh, separated. Then query tuning, analyze and optimize database queries for maximum efficiency. Denormalization, selective denormalization data to reduce need for costly joins. We are going to see one of the example of for about this thing, indexing, query tuning, and denormalization. Let's understand with this example. Create strategic index in common databases. We need to identify common queries. Like here, we can see creating strategic indexes in your database can significantly improve the performance of common queries. So let's understand this. Identify the queries that are most frequently executed and which can benefit from indexing. Means we need to first identify which query we are executing frequently on databases. So this can include queries used in critical API endpoint or backend round jobs. So let's example, find user by email, list all product in specific category, find orders by specific user. So here create index based on our queries. For each common query, determine the column evolved in the where clause, joins and order by clause. These columns are good candidates for indexing. So for example, create index user email on user email. Next, index on category ID, common in product table. We are creating index on this is the most frequently performing operation. So we are creating create index product category ID on products category ID. Next, index on user ID column in order table. Create index on user ID on orders user ID. Next, we are going to see analyze and optimize database query for maximum efficiency. How we can analyze and our query will give us maximum efficiency, that we are going to see here. Identify slow queries. Use database. We can use database monitoring tools or logs to identify slow queries. In PostgreSQL, you can enable slow query logging. Like here, set we can use log for in Postgres. Set log mean duration statement 500 ms logs all queries to take longer than 500 ms. So we can log our queries, which will give us a log for these queries, longer queries. How here analyze queries, use explain and explain analyze command to understand how queries are executed and where the bottlenecks are. Suppose this is our query and we can use explain or explain analyze to these queries. So we can understand queries are executed where the bottlenecks is. So we can improve then our queries. Detailed query analysis with execution time. Explain analyze select star from user where email equal to. So it will analyze our queries. Ensure appropriate indexes are created for column using where clause, join condition, and order by clause. We can ensure indexes are created appropriately on where clause, join condition, and order by clauses. Another example here, create index on email column create index users email on user email. We are creating index on email. uh, then query refactoring, how we can refactor queries. Suppose here rewrite queries to make them more efficient. For example, avoid using select star and select only columns you need. Means we don't need to, suppose we need email, we don't need to use select star from uh, user vary email. We can just use select email, then we can query our example. This is inefficient query. You can see here, and the efficient query here you can see only I am selecting, not star means all. It will hindering our performance, and based on this email, it will give us only specified database column, and it will retrieve and give us. Then we can implement caching as well. So let's understand this. Implement asynchronous processing. We can implement asynchronous processing, like whenever our any microservices produces, we need to consume that. So for that, we can use RabbitMQ, Apache Kafka to handle long-running tasks asynchronously. So it will be processed background continuously. Background workers upload CPU intensive or time consuming operation to background worker processes event driven architect decouple components and enable scalable event based communication between services. This is microservice based, so we can decouple our services. Monitors here, we can use some of the tools as well as this is matrices, latency, throughput, error rate, resource utilization. We can check this. New releases, Datadog, Prometheus, Grafana, these are the tools which will monitor performance of our applications, means microservices. Strategies, bottleneck, scale, resource, optimize, code, enhance observability. These are the strategies we can use. Next, concurrent requests. Allow client to make multiple API requests in parallel to reduce our latency. We can make a parallel requests in our applications with the next task parallelization. Split complex operation into smaller parallelizable tasks to improve throughputs. Distributed processing. Scale out compute power by distributing across multiple services. This is some advanced level concepts. This you need a practice, then only you can explain this to the interviewers. Here continuous improvement, measure and analyzes, continuous monitor API performance and identify areas for improvement, experiment and optimize, test and implement performance enhancing technique and iterative manner, automate and scale, automate performance testing and optimize the sustain high API efficiency. We can do performance testing on our APIs, like sending 100 or 200 or 300 requests at a time. So we can check if our API is responsive or not. And let's understand this caching example as well. Implement caching for frequently accessed data to reduce load on databases. How we can implement caching? So we need to suppose this is the user table. We can make use @cacheable annotation. So it will be get cache, and we don't need to make frequent operation to the database. Another is connection pooling we can use. So we can maximize or minimize our connection pool. Here I have given one example. This you can use in your application. And identify costly join. First, identify joins are causing performance issue. Use query profiling tool to detect this. So we can identify which are the join are costly and explain, analyze. These are the queries we can use to identify the queries performance. And here some sample data I have given. Denormalized data. Before denormalization, create table order is serial primary ID and total decimal. Then create table customer is serial primary name and email. After denormalization, create tables means we use that customer in our order table itself. So it will we have normalized this based on our requirement. populate the denormalized column, update orders, customer name. So we are using in order table itself customer details. So we can denormalize that column. That's all from this video, guys. If you like the content of the video, subscribe to the channel. For these notes, I am sharing in my Telegram group. Link I have given in the description. Please join the Telegram group. You can access these notes from there or message me there. I will help you. Thanks for watching this video, guys. Don't